Hello everyone, welcome to this video on nomenclature of organic compounds. In this video we are going to learn about the IUPAC rules for naming alkanes. In this video we will be taking up the straight chain of carbons that are present in alkanes, and in the subsequent video we will be taking the cyclic chains of carbon. So let us move ahead and get right into the video. So let us get familiar with some of the compounds about which we are going to learn the nomenclature today. In alkanes, all the carbon atoms present in a molecule are bonded together by a single bond. It may be possible that all the carbon atoms present in that molecule are linked together in continuous chain, as are present in example number A and B. Here we can see that the all carbon atoms are present in continuous chain. We can start numbering from one carbon atom and we can end the numbering on other carbon atom continuously. Similarly, in example number B also, we can number the carbon atom continuously without any break, right? On the other side, in example such as C or D or E, we can see that if we would like to count the continuous carbon chain, the carbon atoms which are present continuously in a chain, then we cannot include all the carbon atoms at one time. For example, in C we can count the carbon atoms just as I showed right now. We cannot include this carbon atom right here in a continuous chain, right? Similarly, in example number D, we can either count the carbon chain continuously as 1, 2 or 3, or we can also count it like 1, 2 and 3. Similarly, we can also count continuously as 1, 2 and 3, right? So the first rule of nomenclature of organic compound is based on this fact that we have to find the longest continuous carbon chain, and we call this chain as parent chain. Alright, so in example number E, if we have to find the longest continuous carbon chain, then we can count as 1, 2 and 3, either this chain, or we can begin from the topmost carbon as 1, 2 again and 3. We can take either of this chain as both of them are similar. So we will be exploring all these rules in a stepwise manner, and we will learn how to put the names of all these given alkanes. So let us move ahead. Let us just realize what we are going to learn and put each and every rule as a step in nomenclature of alkanes. So we just saw that there may be different number of carbon atoms present in a continuous chain of an alkane, and hence to represent this many number of carbon atoms we use a specific root word which will help us to identify the number of carbon atoms present in the parent chain. So for example, if we have just one carbon in the parent chain, then we will use the root word meth to represent it. If we have two carbons, then we will use the root word eth. For three carbon atoms, we will use the root word prop. For 4 carbon atoms, we will use but. For 5, we will use pent. For 6, we will use hex, and so on. We can keep a note of these root words for different number of carbon atoms, and this is the first basic and most fundamental step of naming in alkane. So we will be taking the reference of a carbon chain in which we have 6 carbon atoms in the parent chain, and by taking the reference of this particular alkane we will be learning various rules of nomenclature. So let us move ahead and see how we complete the naming of an alkane. Let us move ahead and explore the rule of longest carbon chain. We will take the reference of a 6 carbon atom in order to discuss all our examples. Here we can see that each of the carbon atoms can be linked in a continuous chain, and we will start numbering from one carbon atom. We will end up giving 6 to the last carbon atom. So the root word for representing a 6 carbon atom in a parent chain is hex. We will use this, and in order to identify this compound as an alkane, we will further add a suffix along with this root word, and the suffix for an alkane is "ane". Okay, so we will combine this root word along with this suffix "ane", and the complete name of this compound will be hexane. Now let us make a small variation. In this particular example, we have introduced a methyl group in the 5th carbon atom of this continuous chain. Okay, so now by making this slight variation, we have 3 different chains possible in this same example. Now we have a chain starting from A to B, from B to C, or from A to C. Alright, now if we count the number of carbon atoms in AB, we will find 6 carbon atoms. In BC we will find only 3 carbon atoms. In AC we will find again 6 carbon atoms. So the rule says we have to select the longest carbon chain, right? And hence we can straight away neglect BC as parent chain. We have AB or AC. Either of this can be parent chain. So how to decide which one to take? In this particular example, if we take either AB or BC, or AC, both chains are actually same. We can see this by highlighting the parent chain. Let me highlight the AB as the parent chain. Then whichever groups which are linked to the parent chain are called substituent. So if we mark AB as parent chain, this methyl group right here will be the substituent. And if we mark AC as the parent chain like this, then this particular group will be the substituent. So in both the cases the substituent is a methyl group, hence we can take either of the chain here as a parent chain. Both AB and AC are same. Okay, now after deciding the parent chain and the substituent, we will name them separately. The name of the parent chain, we will use the root word, that is hex, and this is an alkane again, so the suffix will be in hexane. And the name of the substituent will be given as an alkyl group. Here CH3 group is present and CH3 group is called as methyl. So the name of the substituent right here is methyl. Alright, Now after naming the substituent and the parent chain, what we have to do is to inform the position of the substituent in the parent chain. That is, to which carbon atom of the parent chain this substituent is connected to. We can do this in two directions. If we start positioning from A and move towards B, and we can also number starting from B and move towards A. So if we start from A, let us find out the position of the substituent counting from A, that is 1, 2, 3, 4 and 5. So the position of the methyl group will be 5 as per this numbering system. Now if we start numbering from B to A, then the position will be 1, 2, just 2. Alright, so here we have two different positions of substituent starting from either directions, starting from both the directions, and so we will use that particular position which gives lower position to the substituent. So we will use that numbering system which will give lower position to the substituent. We will number the carbon atoms of the parent chain from B to A, and hence the position of the methyl group is second. Once we have determined the name of the parent chain, the name of the substituent and the position of the substituent, we will write the complete name of the molecule as, first of all, the position of the substituent, that is 2, then name of the substituent, that is methyl, then name of the parent chain, that is hexane. So name of this particular alkane will be 2-methyl hexane. Okay, let us quickly put our knowledge into application in this particular example. You can pause the video and write the complete name of this molecule, this alkane. So the name of the alkane will be here. Let me again mark this as A, B and C, and we can see the AB will be the parent chain and this particular group here, methyl, will be the substituent. Now in order to number the substituent, if we go from A to B, we will give this a position of 4. But if we go from B to A, we can see that its position will be 3. Hence, the name of this particular compound will be 3-methyl, followed by the name of the parent chain, that is hexane. Alright, let us move ahead and see more variations of alkenes and more number of rules that will help us to name them. We just learned and applied the basic nomenclature rule in this example, and now let us move ahead and see how to name an alkane if we have more number of substituents. So in this particular example, let me mark all the possible chains for your reference. We can identify a chain starting from A to B, then from A to C or A to D. We can see that both have same length. Similarly, we can identify a carbon chain starting from B to C or B to D. Alright, so AB has 6 carbon atoms in it, AC or AD has 5 carbon atoms in it. On the other hand, BC or BD has only 4 carbon atoms present in it. So without any competition, AB is the parent chain here. Okay, now if we mark AB as the parent chain, then all the groups that are connected to the parent chains will be the substituents. And now we will start applying the rules in a step-by-step manner. First of all, we will name the parent chain. Here there are 6 carbon atoms, so the root word will be again hex, and it is an alkane, so we will use the suffix "ane." So the name of the parent chain, we got it as hexane. Now again the substituents are methyl and methyl. Okay, and now we have to number the carbon chain so as to give a lower position to these substituents. So if we number from A to B, starting from A to B, then we will see that the position of the substituents will be fourth and fourth. Okay, so please take a note here that while positioning the substituents in the parent chain, we write the position of each of the substituents separately, no matter if they are connected to the same carbon atom. Alright, so the position of the first methyl group is fourth, and position of this second methyl group will be 4 also. We will mark them separately. Similarly, if we start from B to A, then the position will be 1, 2, 3. Alright, so here we will get the position of both the methyl group as 3, 3. And as per the rule, we will use the lower value of positions. Hence, the position of this methyl group is 3. The position of this methyl group is 3. And if we have to write the name of this compound on the basis of our knowledge, we will write it as 3-methyl 3-methyl hexane. Alright, and now here is another step that we can use in order to make it short. If we have same substituents repeating, alright, we can group them together and write the name as like this. We can mark the position of these substituents 3, 3, and since two methyl groups are repeating, so we will use a sub prefix di in order to identify two methyl groups, and then we will write the name of the substituent as methyl, and then we will complete the name by writing the name of the parent chain as hexane. So the name of this compound can be written as 3,3-dimethyl hexane. Alright, if a substituent repeats by 3 times, then we will use the prefix as tri before its name. If it repeats 4 times, we can use tetra, and we just saw if it repeats 2 times, then we will use di. Alright, so let us apply again in a particular example. Okay, so here let me just conclude that the parent chain is the one which I have marked as AB, and now we have to position the substituents in this parent chain. If we start from A to B, then the position of the parent chain will be 2, 3, 4, 4. So position will be 2, 4, 4. And starting from B to A, the position will be 1, 2, 3, 3. So position will be 3, 3, 5. So we will use the positioning system which gives lower value for position of substituents. And now you can complete the name of this compound. I'm sure you have already completed naming this compound. The name of this compound will be 2,4,4 trimethyl hexane. So by taking the reference example of hexane, we have discussed a number of possibilities of different alkenes. Alright, you can apply the same rule for any type of alkene. Let us move ahead and see the examples in which we encounter two different types of substituents. In this particular example, we can again see there are a number of carbon chains possible like AB, BC, CD, ED, alright? But if we compare each of these carbon chain, we will find that there are 6 carbon atoms present in each of these chains, and hence they are essentially same. So we will move ahead and mark AB as the parent chain, and hence these two groups will be substituent here. Following the further steps, we will name the parent chain as hexane, and the name of the substituent will be, this is the ethyl group, and this particular group is called methyl, which we are already using a number of times. Alright, now we have to position the substituents so as to give them a lower value. Now starting from A to B, the position each of these substituents get is 3 and 5, while starting from B to A, the position assigned to this substituent will be 2 and 4. So you can clearly decide which one to choose. We have to choose the lower value. So B to A will be the correct numbering system. So the position of methyl group is 2, the position of ethyl group is 3, and the name of the parent chain is hexane. Now we have collected all the information, we have to club them together. And now here is the rule. While writing names, in case of different substituents, we arrange the names of the substituent in alphabetical order. Right? And hence we will compare the name of the substituent by looking at their first letter. In ethyl it is E, in methyl it is M. Clearly E comes before M, so the name of ethyl group will be written first along with its position, followed by the name of methyl group. So this is how we will write the name of the substituent in alphabetical order by comparing E and M of respective substituents, and then we will add the name of the parent chain as hexane. Alright, so the complete name of this particular compound is 3-ethyl 2-methyl hexane. Okay. Now let us move ahead and see this particular example. In this particular example, only variation is that the position of both the substituent is same from either direction. If we start from A to B, methyl will get the fourth position, ethyl will get the third position. So the position will be 3, 4. And if we start from B to A, the position will be also 3, 4. Alright. So if If we have such scenarios in which the position of both the substituents are same, then we will number the carbon atoms from that direction, which gives lower position to the substituent which comes earlier in alphabetical order. So this group is ethyl, this group is methyl. So we will number the carbon atoms from that direction, which will give ethyl the lower position because it comes earlier in alphabetical order. So we will start numbering from A to B. By numbering like this will be the third position, this will be the fourth position. And again we will write the name of the compound in alphabetical order. So first of all we will write ethyl along with its position, and then methyl, okay, and then we will add the name of the parent chain as hexane. So the name of this compound will be 3-ethyl 4-methyl hexane, okay. So here you can pause the video again and go ahead, write the complete name of this compound and let me know in the comment section. I will be uploading the answer in a separate post. We have seen a number of examples in which multiple chains were possible, but all the chains were similar in every manner. Okay, we have completed naming compounds like this in which we were finding multiple chains. Now let us see this particular example in which there may be two different parent chain. Like here, if we identify parent chain as AD and CD, okay, we'll find that both of them will contain 6 carbon atoms. But taking another look, can we conclude that both of them are same? Let us see each of this possibility in a little bit of more detail. So here, let me mark AD as the parent chain. Okay. So if AD is the parent chain, both these groups will be substituents. Now let me mark CD as the parent chain, and in this particular parent chain we will have the substituent as circled here. This entire group will be substituent. So we can now see that there may be two chain possible which have the same chain length, but yet they will be different because the substituents linked to them are different. Okay, in such cases we will choose that particular chain as parent chain which has more number of substituents. So here AD has two substituents linked to it. On the other hand, CD has only one substituent linked to it, and hence we will choose AD as the parent chain. Alright, this rule is applied when there may be two or more chains possible of same length, but the substituents are different. So these parent chains are different. Okay, now you can go ahead and complete the naming of this particular compound on your own. We will also post the answer in the comment section. Let us move ahead and take an example in which we will find a complex substituent. So we will call a substituent complex when we cannot name the alkyl group attached directly. Okay, so here in this example the parent chain will be the straight chain marked as AB, and hence the entire group which is linked to the fourth carbon atom in this parent chain is going to be our substituent, right from here to entire group. So we have to name this particular substituent also as per the IUPAC rule. The rule says that whenever we have to name the substituent, we should always start numbering from the carbon atom which is linked to the parent chain. So always the carbon atom that is linked to the parent chain will be marked as 1. Now starting from this carbon, we have to find the longest carbon chain, longest continuous straight carbon chain. In this particular example, if we move in any direction, we will find continuous chain of 2 carbons only. So let me mark this as a particular carbon chain within this substituent. Now we have to treat other groups within the substituent as substituent and continue naming as we have done before. So in this particular group we have a methyl group right here linked to first carbon. We have a methyl group right here linked to the first carbon. So up to this point we can name it as 1,1-dimethyl Now coming to the parent chain of the substituent, it has got 2 carbons, so its name will be ethyl, since it is an alkyl group. Okay, not ethane but ethyl. So the name of this entire substituent will be 1,1-dimethyl ethyl. And now coming back to our rules for naming alkane, we will follow the same steps. We will write its position, that is its position is on fourth carbon. Then we will write its name. Now the name of the such complex substituent will be written within the bracket. So 1,1-dimethyl ethyl. Alright, and we will name the parent chain of this compound. It has got 1, 2, 3, 4, 5, 6 and 7 carbon atoms, and hence its name will be heptane. We just learned naming the A complex substituent, which is marked as number 1 in this particular example. We completed the naming of this substituent as 1,1-dimethyl ethyl. Let us move ahead and apply the same in naming some more substituents. So let us move to question number 2. Here the branching starts from the middle carbon right here. So we will mark it as 1, and starting from this particular carbon we will find the longest chain. In either direction we will find a carbon chain length of 2 units. So here a methyl group is attached to first carbon, so we will complete its name by writing as 1-methyl ethyl, since there are 2 carbon atoms in the parent chain of the substituent. So this will complete the naming of this particular group. Now applying the same steps in number 3, here numbering will start from this particular carbon, and on moving right from this carbon we will find a chain length of 3 units. So this will be named as In position 1 we have methyl group, and there are 3 carbon atoms in the parent chain, so this will be propyl. You can apply the same steps to discover the name of the substituent given in the question number 4. I am writing the name of this particular substituent directly as 2,2-dimethyl propyl. Okay, so please make a note here that all of these substituents have a dedicated common names as well. In order to find out their common names, which are used quite frequently in the nomenclature system, please watch our previous video on the same topics. Continuing this nomenclature, we will be moving ahead and take up these cycloalkanes, and we will learn the IUPAC rules for naming of cycloalkanes in our next video. Thank you so much for watching. See you in the next video.